Prime numbers, often seen as mere mathematical curiosities, play a crucial role in the real world. Their unique properties make them indispensable in various fields, particularly in cryptography. Secure online communications rely heavily on prime numbers to encrypt sensitive data. Algorithms like RSA use large primes to create keys that protect everything from online banking to personal emails. In computer science, prime numbers enhance hashing functions, ensuring data integrity and efficient data retrieval. They help distribute data evenly across storage systems, minimizing collisions and optimizing performance. In telecommunications, prime numbers assist in designing error detection codes. These codes ensure that data transmitted over networks remains accurate, reducing the risk of data loss during transmission. Even in random number generation, primes contribute to creating unpredictable sequences, essential for secure applications in gaming and simulations. Their mathematical properties ensure that these sequences are less susceptible to patterns, enhancing security. Moreover, prime numbers find applications in music theory, where they influence rhythm and harmony. Composers often use primes to create unique time signatures, resulting in innovative musical structures. In the world of art and architecture, prime numbers inspire designs and patterns, adding an element of intrigue and beauty. From the layout of city streets to the proportions of famous buildings, primes contribute to aesthetic appeal. In summary, prime numbers extend far beyond the classroom, impacting technology, security, art, and science. Their applications demonstrate the profound connection between mathematics and the real world, showcasing how these seemingly simple numbers can shape complex systems and enhance everyday life.